welcome back. In my previous videos, I've done the basics of linear equations, activity 10, 11, 12, and 13 from SpringBoard Course 3. This video is about the embedded assessment 2 that follows after activity 13. It says right here, embedded assessment 2 used after activity 13. The name of the embedded assessment is linear equations and rate of change. Who is that? So before we start any of the questions, let's read this problem page. And this embedded assessment number 2 is on page 174. So let's start reading this. The problem scenario is the Athletic Booster Club at C. Brown High School publishes a fall sports program for the athletic department. The purpose of the program is to raise funds for the new scoreboard in the football stadium and to highlight each of the athletes participating in fall sports. The program contains interviews with coaches and athletes, schedules of games and other events, and the brief biographies of each athlete and coach. The Booster Club members must consider how much to charge for each program and how much money can be raised. So let's start with number 1. Number 1 says the finance chairman has researched previous year's sale records and organized the results in following tables. Graph the data on the grid like the one shown. So you can graph the data over here by the points. So the program sale price, which is right here, is your X, and the number of programs sold is right here, which is your Y. So you just plot the points based on these two. So let's start with number 2. Number 2 says the relationship between the price and the number of programs sold is linear. Justify the statement using both table and graph. So we can justify the statement using the graph because since a graph makes a straight line and only linear equations make a straight line, we can know that this is a linear equation and linear relationship. Also, we can justify using the graph the table, because if you take these 2 points, for example, if you take these 2 points, 2.5 and 5.5, and you use change in y over change in x, you get negative 250. And then you can cross-check that by using 5.5 and 7.5, and you again get negative 250. So it shows that the slope is negative 250. That means if something has a slope, that means it's a linear relationship. So let's start with number 3. Number 3 says to draw a line through the points on your graph. We already did that, or if you didn't do it, you can do it now. So let's do number 3A. So 3A says determine the slope of the line through the points. Describe the meaning of the slope in this problem situation. So we already determined the slope, which is negative 250. I wrote that. And the meaning of the slope is for every program price increase, the number of programs sold decreases by 250. So we know that it decreases because the line is decreasing and not increasing, because it's increasing as you go left and it's not increasing as you go right. So let's go to 3B. 3B says use the data in the table, the slope determined in part A, and the graph to determine y-intercept of the line through the data points. Describe the meaning of the y-intercept in this problem situation. So you can probably find the y-intercept, and we've done a lot of finding the y-intercept and determine its meaning. So I want you guys to do 3B on your own, because you already had the graph, the table, and the slope. So let's read 3C. 3C says write the equation of the line through the data points in the slope-intercept form. So in 3B, you determine what the y-intercept is, and 3A, you know the slope. So you can combine that together and you can make an equation for 3C. Okay, so now let's move on to problem number 3D. 3D says, is the relationship between the price of the program and the number of programs sold directly proportional? So is these two relationships directly proportional? Justify your response. So we know that this is not directly proportional, and that is because we have a really big clue right here, because the line does not pass to the origin. And we know that in the previous activity 13, some previous video that I did, that we made a conjure that all directly proportional relationships have to pass through the origin or have to have 0, 0 in their table, or should not have a y-intercept in their equation. But this does. So this is not a directly proportional relationship because our evidence right in front of our eyes, it does not pass through the origin. So that would be a justification, and we would say it's not a directly proportional relationship. So let's move on to the next page, which is page 175. Embedded Assessment 2, use that to activity 13. That's the continuation of the embedded assessment. So we're still using the Athletic Booster Club and their problem to solve in this page too. So let's read number 4. Number 4 says, assume the slope of the line was changed to negative 425. So from negative 250, it's changed to negative 425. So write the equation. So 4a says, write the equation that could be used to represent this new relationship between the price of the program and the number of programs sold. So you would write the same equation, except instead of the slope being 250, you would change the slope to negative 425. So this is pretty easy. So let's go to 4b. 4b says, describe the meaning of the slope in this new equation. So the meaning of the slope would be for every program price increased by $1, the number of programs sold would decrease by 425 sold. So let's go to 4c. 4c says, describe any changes in the graph that would result from this change in slope. So let's go back to the graph here. So the graph would look more vertical than like this. So the graph would be more kind of like this. I'm just going to do a rough sketch. I don't know if it's correct or not, but this is more vertical than this one. So it's going to be more vertical than the graph we drew here, line we drew here. So let's move on to number 5. Number 5 says, assume the y-intercept of the original line was changed to 3000. So write the equation that could be used to represent this new relationship between the price of the program and the number of programs sold. So in this, you would keep the y-intercept the same. That means, you would keep the slope the same. So the equation would be y equals negative 250x plus 300, except instead of the y-intercept you found out in the before problem, you would use plus 300. So let's go on to 5b. 5b says, describe the meaning of the y-intercept in this new situation. So the y-intercept would be, if the program was free, 300 programs would be sold. So that's the meaning of the y-intercept in this new situation. So let's move on to 5c. 5c says, describe any changes in the graph that would result from this change of y-intercept. So since I don't know the y-intercept of the previous one, but we can know that the change would be the graph would move more up or the graph would move more down. So that would be the change in graph. So let's move on to number 6. Number 6 says, L&L Printing will print the program for 250 plus an additional 1.5 per program printed. So let's underline these two. So this is an important one and this is important. So since this is a one-time fee, this would be our b or our y-intercept, and this is our constant variable cost. So this will be keep on changing. So this 1.5 will be our slope. So and then let's read 6a. 6a says, write the equation in slope-intercept form that could be used to determine the total cost C to the Booster Club for printing the given number of program P. So I don't have space here. I'll write the equation over here. So our equation would be C equals 1.5 P plus 350. So this would be our equation for 6a. So let's move on to 6b. 6b says, graph the equation on a grid like the shown above, like the one shown. So we have so many graphing, like over here, number 1 we graphed, and also in other places we graphed. So I'm pretty sure you could do the graph on your own. Let's just make a table of values using this equation and then use that points to graph and then use a straight edge to make a line. So that's easy. You already did a lot of graphing problems. So let's move on to number 7. Number 7 says Red Baron Printing will print a program for $1.82 each. Let's read 7A. 7A says if attendance for the football game averages 1,500 fans per game, which printing company should the booster club choose? Show your work and justify the response. Well, you can derive the equation for each program. So this is this equation is for the L&L printing. So let's write that so you don't get confused. L&L, and for the Red Baron, I'll just abbreviate to RB. So for RB, it is 1.82x equals y. So you can plug in 1,500 for p and for x, and you can see which of the costs is the lowest, and then you can tell the booster club which option they should choose. So that's how you can derive this, and this is just plugging in, substituting the number, and solving for c or y. So let's move on to 7B. 7B says, which printing company contract is an example of direct variation? Justify your response. So let's look at the L&L first. So we can see that the L&L has a y-intercept of 0,350. And we can see that the R&B doesn't, because there's no y-intercept, there's no additional cost, it's just cost for each print. So R&B would be the printing company with the example of direct variation. So Red Baron would be, because they don't have any y-intercept. So that would be justification that you would refer back to this equation that it does not have any y-intercept, and you would say that Red Baron printing is an example of direct variation. So thank you for watching this video, and on the next video we'll be doing activity 14 from SpringBoard Course 3.